Hello everyone. So today I'm going to cover on Agentic AI, Agentic system. So this is my agenda. So I'll cover on the machine learning. I'll start with machine learning, then large language model, Agentic workflow, AI agents, Agentic AI architecture, governance, and one use case with code. Okay. So, but before I start, so there is a disclaimer. So the content I'm going to present, right, is completely based on my personal experience to date. Okay, and the publicly available information. So why I'm saying this, because this is a very rapidly evolving situation for AI, right? So every day, every week, we're getting something new. So, what I'm covering today is based on the current facts, current state of knowledge. Okay. So, let's move to the original content. Okay. So, the first slide is related to the waves. Let's understand the history. So, I given only three waves here: wave 1, wave 2, wave 3. So, first wave, it start with the rules, the rigid handcrafted instruction that told machine to do exactly what information we are asking or information we are providing machine to do. The second is the predictive model. So the predictive model is the pattern recognition. So we have data, we have the historical data. Out of those historical data, the machine needs to identify the patterns, identify the correlation, okay, and so that it can predict the output. That is your predictive model. The third wave is your generative model. That is a creation era. So today we are in the era of generative AI, the system that not only just recognize patterns, right, but it create new possibilities like code, text, image, any content, right? Anything you can generate using the generative AI. So basically, this evolution marks a shifting from a machine that just follow instruction to machine that discover insight, and now the machine that generate and act. This is the entire evolution so far. Okay, let's understand a little bit about the machine learning, how it start. So first, supervised machine learning. It says supervised learning with a teacher. Two example I have given here. One is classification, another is the regression. So in the classification, you will classify the data. One example is your email, let's say whether it's spam or not, right? You are classifying that. So by understanding your past data, past pattern, so it can identify whether it's spam or not. Okay. So another is a regression. Regression is the predictive model. So it will predict the value by understanding the historical data or the trend data. It will predict. One example I have given here, like your house price. By looking into the previous data, by understanding different features, it will understand what could be the price of the house. So we have classification and regression in supervised machine learning. Okay. Now let's move to unsupervised machine learning. So in the unsupervised, this is unsupervised. So your data is not level. So basically your model needs to find what is the hidden patterns. So data you are providing, this is not properly leveled. So your model needs to figure out that. So there are two different way I have given. One is your clustering, another is your association rule mining. In clustering, basically it will group the similar data. Example I have given is, let's say you wanted to understand the purchase history of the customer, how exactly customer is buying, you will put into different cluster. Okay, so that is your clustering. And association mining is basically finding the relationship. I mean, so the example is, let's say when the customer is buying X, so customer is also buying Y. There must be some relationship, right? One classic example here given is kind of when customer is buying diaper, so it also buying beer. That is one association, or you can imagine similar things like opportunity, cross sell, upsell kind of things, right? So it's association mining. There are common algorithms I've given here: k-means clustering, hierarchical clustering, etc. That is part of your unsupervised learning. So next is the reinforcement learning. So name itself is the learning model. So reinforcement learning, what it how it works? It trains on AI through a reward model, similar to teaching it to play a video game. For example, video games like, let's say, chess or Go, right? So for one example, in the chess, a good move receive award. If it is complete, if you are winning by doing that move in the chess, that means a reward. That is a reward, right? So the process fundamentally involves a cycle of observation, action, and the continuous learning. There are few more examples. Let's say optimizing the routes for the vehicle in the Google Map. If you are using Google Map, it will show you the best route, right? Because it's learned in that way, with the rewards, right? And also your driverless car also work in the similar context. That is the reinforcement learning with the reward. Okay, let's move next. So far we have seen supervised learning, unsupervised learning, and reinforcement learning. The analogy I have given here is supervised learning, learn with a teacher. What teacher told you, if you'll see the image of the cat, so that you can identify this is a cat, because you have already learned with the teacher, okay, or the supervisor. That is the supervised learning, right? In the unsupervised, so the model itself will identify what is the hidden patterns. It will cluster those data or the associate the data. In the reinforcement learning, so one example I have given, another example I have given here, like a child learning to ride the bike. If they crash, then it's negative. If they complete, then the success. That is the reward. Okay. So that is your reinforcement learning. Okay. I given just to understand the basic on the machine learning. So this is your trend test model. Trend test, split, and the model evaluation, right? So one example of, let's say, the lead conversion, whether the lead will be converted to opportunity or not, right? So there are the past data, past lead data you need to capture, you need to find the patterns, and basically how it work. Basically entire data set needs to split into two parts. That is a train test, a train and test. It can be, the percentage can be 80-20, or it can be 70-30, but it needs to be split. The first set of data the model needs to be trained. In the second test of data, model need to be tested. Okay, and finally, so that it can predict whether it will be converted or not. So you have the input; those are the features, and the output is your the target, that whether it will convert yes or no. Okay, that is your train, test, and model evaluation. Correct. Okay, so neural network. This is the most important thing. So all the deep learning, the GPT, etc., even what we are experiencing in the AI, right? Mostly these are based on the neural network. So then how it work? So the neural network is inspired by the human brain. How human brain work with the neurons, or it's considered dendrite, and there are multiple things, right? So exactly it work in similar ways. It learns patterns by transmitting information through interconnected neurons, right? So then if you look at, there are different layers here. One layer is, of course, input. Next is hidden, and the final layer is the output. It's We have three layers here: input, hidden, and the output. And there are adjustable components. You can say it's the weights and biases. By adjusting those things, you can improve your result. Okay, you have to adjust those bias and weights, so that your result or output can be improved, or probability can be improved. And next is the activation function. So activation function, how it works? So it determines the neuron's decision to pass information to forward or backward. If you know about the forward propagation or backward propagation, um, you can understand this, how the activation function work. Okay, so if I summarize, we have multiple things here. We have neurons, we have layers, we have weight and biases, and the activation function. These are the key things for the neural network. One, just to present in pictorially, I have given here the simple neural network and the deep learning neural network. In simple, only one hidden, but in deep learning, there are multiple hidden networks. And one example here is, if you are putting one image to identify who is this person, then it goes through multiple layers. identifying edges, identify combination of edges, identify features, then combining those features and predicting who is this person. So look at the below areas, right? How it's the edges, combining edges, the features, etc., and then finally predicting the who is this image. Okay. Uh, so this is your neural network and the deep learning neural network. Okay. Before going to the large language model or generative models, we need to understand how it evolved so far. Okay. So first is the classical neural network, that is your CNN, convolutional neural network. So how it work? Basically, it identify the lines and circle of the image and scans small areas. Maybe you can say the even the pixel also. But it work in sequentially. So if your input is photo of a cat, then output is this is a cat, because it's already trained. So by verifying those features, or you can say circle, pixel, lines, etc., and different layers, so it can identify this is a cat. In recurrent neural network, so this is a little bit different. So you can say this is a short-term memory along with a neural network. So then how it work? It process data sequentially, step by step, allowing it to maintain a memory also. Okay, but there is a limitation. So it good at recalling only the recent information. If you are passing a small sentence, maybe it can predict what could be next word, right? It can understand the last and few words earlier word. But let's say if you are passing entire paragraphs, so maybe it cannot understand, or it cannot store what is the initial words in that paragraphs. Okay, so these are the limitation in the recurrent neural network. Okay, so now we move to the long short memory. So the long short memory address the issue in the RNN. Okay, so it introduce your long term memory. Let's say it introduce the long term memory. So it can return information over longer sequences. Again, the drawback is LSTM is very slow. The processing is slow because still it process in the sequential nature. It's not taking the input in parallelly. Let's say if you are passing I group and trans, still it's splitting and processing those sequentially. So it's similar to RNN, but still having a better memory. So CNN, RNN, and LSTM. So now all the GPT or the foundation models, what we are seeing right now, right? Everything using the transformer. So the transformer, we call it is parallel genius. Sorry. So in the transformer, we have different things. We have self attention, we have positional encoding, we have multi-head attention. We are going to see in the next slide. So, but this architecture is now the fundamental core of large language model. The transformer address the limitation of LSTM or RNN we have seen so far, right? Which was too slow for large dataset. But it introduced self-attention mechanism to understand the meaning of the words, right? So allowing the model to process the entire input in sequence simultaneously. Okay, it's a parallel genius. What you can say? It's a parallel genius. Let's understand more by considering the LLM. So LLM, understanding the natural human language. So if you look at here, we have different stage. Input stage. First, that is the text number. The second stage is the transformer stage. That is the brain. And third stage is the number to text. So how it work? So the stage one in input, if you look at, there are multiple steps. First is the tokenizer. So the LLM breaks the text into chunks called as token. If you look at the example, the cat sat on the mat. Sorry, mat, that is the predictive. The cat sat on the, right? So then it's split to multiple tokens. Then it embed and encode. So this is like a big lookup table. So every token is swapped for a unique list of number. That is, you can say the text number, right? That is the first stage. And the second stage, The transformer stage also we discussed in the earlier slide, but to understand more detail, so the first step one is multi-head self-attention. This is the self-attention. How it works? It allow every word in the sentence to look at every other word to figure out what the relationship, how it is interconnected, how these words are interconnected. Okay. So then in the MLP, that the thinker, so once the attention layer has gathered context from surrounding words, this layer process the individual words vector based on what it just learned. That is your feed forward network or MLP. In the third stage, again we have three steps: on embedding head, submax, and the selection. In the on embedding head, basically this layer process vector and compare it against the entire dictionary the model knows, because right now the model they have uh, the data we have very big data we have right now with the models, right? So then it assigned a score to every possible words in the dictionary based on how it just learned, how it trained. Okay, so then in the softmax the scores are returned to the percentage, and the selection, what is the maximum probability. Okay, and then from maximum probability, let's say here in the math having 85%, and the answer is, the prediction or answer is the math. Okay, this is your LLM. Okay, before moving to the agentic system, we need to understand few fundamental concept. Let's go one by one. First thing is comparison of the AI prompting. So what is AI prompting? So I have given three key prompting technique here: zero shot prompt, few shot prompt, and chain of thought. In the zero shot, model is asked to perform the task without any example or prior context. You're just asking some question without giving the prior context or examples, right? But in few shot, we just improve that. We are giving some examples or some context or some kind of a role. We are providing some details to the agent so that agent can give you the better output. So agent will, basically the zero shot prompt, this helps to set the style and the structure of your output because we are providing the examples. Okay, so that is your zero shot prompting. So next, the chain of thought. So in the chain of thought, this is we are adding little bit cognitive layer to our prompting technique. Okay, so this was not earlier in the if you look at the, remember the GPT, right? It was not there, but when GPT-o came, so they added the reasoning. Okay, so how it works, let's say you are passing one math example here. If I have given one problem here, right? So math problem here, so it split the math into different steps, then process, and finally it will give you the output. So basically in the reasoning layer, it's splitted into multiple steps and process, then give you what could be the probability and what could be the answer. That is a chain of thought in the chaining. Vector DB. So vector DB, this is not our conventional database like let's say SQL or NoSQL. This is completely different. So basically this convert data into vector embedding. So and it represent meaning as coordinates in multiple dimensional space, in multi-dimensional space. Basically it understand the meanings, not exact the keywords, or you can say the string, right? It's understand the meaning of that word. Conceptually similar item are placed close together. One example, if you look at here in the coordinate, right? Cat and kitty may be similar, right? And another example you can imagine, like let's say orange and apple, right? So this can be part of another cone, another dimensional space. Okay, because these are the similar items, fruits. So to understand more, let's say your user request is, I need a smartphone with good camera. But if you search this search keyword in your SQL or NoSQL DB, unless you have the exact phrase matching smartphone or good camera, it will not return. So, but in terms of vector DB, it will not only search those details, it will also try what is the similar meaning of the data. In terms of smartphone, If there's smartphone or good camera itself, the word itself is not there, but iPhone 15 is there. So it will understand iPhone 15 is a good a smartphone with good camera. So it will return iPhone 15. So it is completely different from your conventional DB like SQL or NoSQL. So it's understand the meaning of data and kept it in the multi-dimensional space. Then RAG. So you understand the vector DB, right? So in RAG works in two phase. So RAG actually retrieval augmented generation. You may heard about this, right? So let's say you are developing one agent that will search for your content. It will answer. It will find out the answer from your content, and right. So there are two phases. One is the ingestion and indexing. So here we are uploading data, and the chunking, that is the segmentation. Then the embedding into the vector DB. And the next page, let's say user put some query, and then query will go to the vector DB. It will search, finding this the semantic search, and it will return to the LLM. So now LLM will augment that and return back to the user, because the vector DB, what vector DB will return, so it may or may not that much well formatted, right? So now the LLM will do by putting more context to that and will return to the user. So that is the phase one and phase two, correct? The phase one kind of a document uploading, chunking, embedding, etc., and phase two kind of a query and augmenting. MCP, Model Context Protocol. So again, you must heard about this, right? So MCP basically it work like USP for the AI. So AI model connect to the MCP layer, and MCP layer connect to the different source like data source, API or tools. Okay, and it work in again it's a client server model. So let's take one example. Let's say you are developing one agent outside of Salesforce, but that agent needs to connect to Salesforce to fetch let's say opportunity detail or the lead details, right? So here your host is your outside agentic system is your host, and your server is the Salesforce MCP server is your server. Now the host needs to connect to the client, that is the MCP client, and MCP client needs to connect to MCP server, that is the Salesforce. Okay, so again this is host, client and server architecture. Okay, that is your MCP. Okay. So we understand at least the foundation, or you can say the basic concept of machine learning, and a few fundamental key things for the agentic system. So now we have to move from the generative to the agentic. Generative is mostly, you can say it's a co-pilot, that is passive, and where agentic is active, that is your autopilot. It's a kind of a action oriented, or we can say the goal oriented. We are going to discuss on this more, but now we have to transition from the generative or the standard machine learning to the agentic AI. Okay, again, moving before to the agentic system, let's understand few more things. The shifting from deterministic to the agentic workflow. What is agentic workflow? Why we are moving from the deterministic workflow to the agentic workflow? So the deterministic, if you look at now, even where let's say we are doing writing code in Java, .NET, Python, or in Apex also, right? So these codes are mostly fixed, linear, but it's rigid. If it is fails, if it conditions are not met, then from that that statement it will return. That is your rigid. But in agentic world, this is more goal oriented, utilizing reasoning and an iterative process based on the intent and the context. This is not linear. This is iterative and goal oriented. Just understand from the coding perspective. I have given one Python code here, that is the deterministic code, and right side again the Python code, that is your LLM powered agentic flow, right? So here you are developing something that will answer all your question for program management. Let's say for the agile, for Gantt chart, etc. It will answer. So what you will do, you have your if condition and it will return what is the answer, and else if else conditions are there. So here in the LLM part, so you have your prompt, you have your instruction where you will define what is your role and what is your content, like you function as an expert in the program management. Okay, this is very straightforward. You are not doing any hard coding here. But in the limitation here is, let's say your user asks question about Scrum of Scrum. It's not there. It cannot answer. But here it can answer, because it will go to LLM. So LLM will give the answer. Okay. So this is not hard coded. This is more intent or context or goal oriented. Okay. That's how it different. The agentic flow is different. Understand more. Deterministic flow, we know this is our workflow. Okay, condition and the result output. And when agentic, if you look at the input prompt, then goal splitted to the sequence of task, then the task execution with the help of tools if needed, then it evaluate, then if it is satisfy the evaluation, then the goal completed, or else it will go in the iterative process. That is your agentic system. One example here is, let's say user prompt is, I need to change my shipping address for this order. So how LLM will understand? So your intent is change the address. That is your intent for this order. So what it will do? It will go to a tool where exactly your order information is available. So it will go there and your find out the old address, and then it will update the address. Then it will draft email and send the email. This is a very straightforward. There is no hard coding, no condition, if else, nothing is there. Understand the intent, look up the tools, and execute your user query. Okay. To understand more details, how it works. So first thing is the task decomposition. So first we split goal into bite-size actionable task. Then we are defining the orders, in which order we need to process, whether it's sequentially, parallelly, and the decision point. If there is anything we need to put some decision point, some sort of path, right? We need to define the path there. And tool integration, we just discussed, right? If there is any tool we need to look up, we need to integrate the tool. And the context management, we have to store the context. If you need to if the agent needs to answer better way, it agent need to understand the context. Okay, remember the key fact across the session or across the step. That is your agentic agentic workflow design. Okay, so we'll move to, now we'll start with agentic AI system. Okay. Okay, now let's start with the agentic AI landscape. Okay, so I given here in three different sections. So I'll start with the third section first, the structural lens. What is the structure of agents? The single agent, multi-agents. Multi-agent, again, the two category, the vertical and the horizontal. And the architectural lens, if you look at, we have different types of agent. Planner agent, orchestrator agent, worker agent, supervisor, and router. We are going to discuss on this. Okay. And the logic lens. So logic lens actually what the logic on which basis agent will work, right? Then let's say the simple reflex, it work on if and then logic, right? No memory, nothing. The model base, having some internal state, it remember the past to understand the present. Okay, that is your model base. And third is the goal base. We discuss on this. You already you have discussed that is the goal base. You have a target, and you need to do some plan, some action to reach the goal. The utility base, you should have some trade-offs. Okay, risk and rewards. And the learning agent, it improve over the time by learning some things or by analyzing its own performance. Okay, that is your learning agent. Okay, so we the entire landscape I have given in different ways, like the structural, the architectural, and the logic lens. We'll discuss a more detail specific to the agents. Now let's start with the agent. So who are they? The agent is an entity capable of perceiving environment, understand the environment, process the information, it will take some action to achieve the goal, and adapt its behavior based on experience, or adapt to the environment also. Understand the environment in better way and adapt, right? So that is your agent. So the building blocks. So there are 4 key building blocks I have given here: the sensor, the brain, the hand, and the memory. We can just imagine kind of a human. Okay. So the sensor, or you can say the perception, is to understand the environment, to see the environment, right? So it will identify what user request is coming. The brain, it will process, it will do the reasoning, and it do the planning. Okay. And next is the hand, it will take the action. And the memory, you'll store things. You understand the context, the past, or the history, and the continuity, the present. That is a memory. We'll discuss on each and every blocks in more details. Okay. So but you may have this question, right? So then where is LLM? If agent is doing everything, then where is LLM? So actually LLM is the central nervous system for this agentic, for the agent or agentic system. Okay. So you can say, for the sensor, actually it is taking the raw noise and converting to the structured data. In the brain, it's helping to do the reasoning. It's helping to break down task. Okay. And or to understand goal. And in pillar 3, the hand, so it helping you to decide which tool we need to connect. Okay. And for the memory, it can help you to store, also it can help you to retrieve the context from the past interaction, or it can also summarize a history and tracking state, etc. So LLM is everywhere. That is the central nervous system for the agentic system. Okay. We'll move to next, context management. So why context management is important here? Because LLM itself is stateless. It doesn't store anything. Now you can think in this way. So if LLM is the brain, then context is the environment, its memory, and the instruction that brain used to make a decision. Okay. So a few category I have given here. The first is the task context, that is a goal. So what is your task in terms of quoting agent? Let's say your task is you can offer up to 10% discount without approval. That is your task. Working memory, that is the short term, or you can say the working condition. One example is I have already checked the inventory. Now I need to calculate the shipping cost. That is the exact that moment. That is the working memory. The grounding data, you need to connect to the long term memory or the grounding data. Example is retrieve the specific pricing for the partner X. Okay. Next is the environment state. Once you have all these things, so you need to take the decision, right? I mean, that is the dynamic context, that is not static. Okay. So example is, let's say the tool return the stock is 0. Now what agent will do? So agent will move from the create code to the check restock date when stock will be available. Okay. That is the context. You need to understand the context first. Okay. So next is the reasoning, because 4 building blocks we have given there, right? That's the reasoning. So AI reasoning is kind of figuring out what to do next. That is the reasoning. What to do next. That is the cognitive layer, the brain. Okay. So there are few reasoning patterns I have given here: chain of thought, the react, tree of thought, graph of thought, and the reflection. I will give you example from each pattern in the next slide. Okay. So chain of thought. So chain of thought is kind of a chaining. So let's say your input is you need to find out the growth, year over year growth. So then what is your thought? What in the chain? So first is get the revenue 2024 revenue, then get 25 revenue, right? And if you have to find the growth, then you have to subtract. That is the chain of thought working in a chain. The react, two part, the reasoning and acting. So let's say user ask where is the order or why the order is late. To do that, you need to understand the context first, right? So what is your thought? So first is agent needs to check the shipping status. Then the action, you need to call. There is a separate tool. Let's say see in the CRM, you have the order details or order status is there. You need to call that. That's the action. You need to call the function. Let's say get tracking function is there. You need to call that. Then what is the observation? Once you get the detail from the external tool, let's say it's showing it's held at the custom. That is your observation. Now this is kind of a iteration process, iterative process, like your thought, your action, and your observation. That is the react. A tree of thought, it's a kind of a tree. Remember, recall your data structure, right? It's a tree structure. So you have multiple branches. So one example is, let's say the ask is develop a plan to enter new market. So you have plan B, plan C, plan A, plan B, plan C, right? So now you have to figure out, let's say plan is launch a direct to the customer campaign. And plan B is, let's say, partnering with the local distributor. A plan C is, let's say, sell online something, right? Um, so, and then you have to figure out what is the weightage against what is the score against each branch, right? So then you will go which branch having the more score, then you have to select that branch and then it will follow the path. That is the tree of thought. So graph of thought, it's a kind of a graph, or you can say kind of a merging or synthesize, right? So the best example can be, let's say you providing multiple documents and you're asking LLM to just summarize this thing. So that is a synthesis, document synthesis. It work on the basis of your graph of thought. Okay. And the reflection is a kind of a, you can say, self correction. So what you are doing, let's say you are writing code, though you have agent writing code, but the code need to be a review, right? You have actor and you have critic, and the reviewer needs to find out the errors, and then it needs to be correct. That is the self correction. It's a kind of a reflection. Okay, let's understand. Remember the agentic landscape, right? The structural landscape. We have multiple agents there, right? Let's go one by one. So direct prompt, you are just asking question, you are getting answer. Nothing is there. No memory, no processing, etc. Knowledge augmented prompt. It's a kind of similar to your RAG. If you recall the RAG, you have LLM on top of you have your own knowledge base, and you have some persona. So then what it will do? It will process and it will augment and it will answer based on the knowledge and the persona. Okay. The planner agent. So planner is basically who will do the planning. Basically, planner agent turns big fuzzy goals into clear and step-by-step plans. It's a plan. It can do sequencing, it can prioritize, and it can do the delegation, right? So there are multiple ways to do planning. It's a forward planning from current state to the goal, backward planning from goal to the current state, and hierarchical planning, it break into the multiple subtasks, and the conditional planning, plan for different scenarios. The continuous planning, adjust plan during kind of a dynamic state, right? So adjust plan during the execution. So these are kind of planners. Let's take one example here. So the user input is plan a trip to Paris, and this date and the hotel, etc. Here in the near to Eiffel Tower, right? That is the user input. So what the planner agent will do, it will break into multiple tasks. Find the flight, search hotel, generate recommendation, validate preference, and the book the trip. Then you have your tools, um, Then step 4, again, you'll ask the follow-up questions to the user or the customer, and then the memory, right? It's a simple example of planning. Tool using agent. So as I said, right? So you need to so remember the building blocks of the agent, the action. You need to connect to the external tools to find the information. If you're building agent inside Salesforce, maybe at some point you need to connect to external system. Let's say the Oracle, or let's say ServiceNow, or any tool you need to connect. Correct? That is tool using agent. So how it work? How the connection actually work? Then first the discovery of tool. Who is tool you need to connect? Then the function calling. The function calling is the LLM determines the appropriate tool, and I mean, it's create a kind of a JSON. Okay. Basically, it contain the details about the tool, the name, and the necessary parameters. That is the function calling. That LLM determines that, right? And the execution is the client. Let's say you are doing through MCP. The MCP client, it will do the client interpret the JSON output from the function calling, and it trigger the actual API, or you can say your MCP server, right? And the observation is the result. Once it is returned, the result from the execution is then returned to the LLM. Okay, this is how your tooling agent work. Then worker agent. So these are actually your specialized agent having some specialized skill. Who are, if you look at here, these are the specialized agent having some specialized skill. Document summarizer, text translator, data cleaner. These are the workers. They are the special having some specialized skill. These are the worker agent. Okay. One example is routing agent. So we'll discuss on this when we discuss on the multi-agent. But routing agent, understand this. Uh, this is kind of a the agent who will delegate something to different worker agent, because worker are having some specialized skill set, right? So you have one worker math, one history, one code assistant, right? So as per your requirement, so routing agent will delegate to the specific skilled agent. That is your routing agent. Okay. Now let's come to the agentic AI architecture. Again, here we have 4 key things. One is reasoning. We already discussed on that. All the reasoning patterns we already discussed, and that is, you can imagine, that is mostly related to a single agent. Your everything, your chain of thought, your tree of thought, reflection, etc., right? So that is your reasoning pattern. So orchestrator, we are going to discuss this next. Memory and state, somehow we discuss some part in the context also, little bit we'll discuss little later also, and also the governance pattern also. Although I would say that the first two are more important, but let's look at 3 and 4 also later. Okay. Okay. Recall, before moving to the multi-agent, recall the agentic workflow. We understand what is the difference between the deterministic and agentic workflow. So this example is your classic delivery workflow process in the deterministic way. You have receive a request, you check the inventory and check whether, then dispatch, find the route, then the dispatch team then deliver. If not, then retry, escalate, etc. This is a classic deterministic workflow. But if I need to convert this to the agentic workflow, this is my agentic workflow. So I have a strategic agent who is controlling inventory agent, weather agent, and the road agent. Okay. Then there is a condition. Okay. The branch, if it is ready to dispatch, then it will go to dispatch agent, then confirm delivery. If it is not, then it will replan. This is a very useful example of the multi-agent. I just converted that the deterministic workflow to an agentic workflow, but with multi-agent system. We discussed on the single agent also earlier, and this is your multi-agent where you have multiple agents involved. Okay. Now let's talk on the multi-agent. So multi-agent is you can say where you have multiple agents. But having multiple agents, they cannot work very independently, right? You have to compose those things. You have to define their roles, their responsibility, etc. Right? So the agent hierarchy. First thing is the agent hierarchy. You have parent agent, you have sub agent. Then you have one orchestrator agent who actually control your sub agents. One is this, I mean, in the sequential agent, so it execute the sub agent one after another. That is in sequence. In a parallel agent, so your orchestrator execute the sub agent simultaneously. Okay, in the loop agent, execute your orchestrator execute the sub agent in the sequence and a repeating step in the loop, right? So now, so first the structure, the second is the orchestrator, and third is the interaction. And in which way they will communicate, right? If they will work independently, it will not complete the goal, right? So first is the share state, kind of a, it's a common area where they will share the status. Let's say this is, you can say, the primary method of the passive communication along the agents. And you have a shared session, and then delegation. Of course, imagine you have parent and sub agent. So now it need to delegate, or you can call the router, right? You need to delegate to the specialized agent, right? And explicit invocation, that is the agent tool, enables an agent to utilize another base agent instance where you know to call. We discuss on this, the tooling agent, right? So you have multi-agent here, you have structure, you have orchestrator, and the interaction pattern. Also, there is one more important thing we'll discuss a little later. But before that, understand one example. What we just discussed in this slide, where you have the orchestrator and the interaction pattern. Let's discuss one. There are multiple examples actually. I just took only 5 examples here, right? So first one is the sequential. One example is here. Um, so one is researcher, then it's handing over to the writer to the editor. This is going in a sequence. And in the concurrent or in the parallel process, let's say you have a goal, you have agent A, that is US specialist, agent B, that is U specialist, then it's go to the synthesizer, that is the agent C, and final the answer. So agent A, agent B doing parallel task here. Okay. The third is the human in the loop, where if you at certain point decide whether you need human intervention or not, right? If one example is, let's say you have the financial transaction involved, let's say the classic example is the credit card information, where you take help to book your trip, but when you need to uh, uh, like do the billing, but you have to put your credit card information, right? So at that moment you will ask the human agent to provide the credit card information, right? Your agent directly cannot do the transaction from your credit card, right? So better there should be some human in the loop, where you ask human whether to approve or reject. Okay, that is a human in the loop. Now the hand up routing, we already discussed on the routing agent. Okay, and the group chat, you can say, where you have remember the interaction and the communication mechanism, right? You have a shared state. Agent A and agent B, they are discussing with each other, and the sharing status, and they are interacting with each other. Okay, at kind of a collaborative meeting. We'll discuss a little bit more on this little later. Next, move to the orchestrator agent. In multi-agent composition, that was our second block, where we discuss on agent as orchestrator. Orchestrator is basically, it coordinate the execution of multi-step plans. it track, it delegate, and it adapt as needed. Okay. So in better way, if you look at what an orchestrator should do, it will delegate the task. It will handle the response from the workers or the connected agents. It will maintain the state, keep track of the progress, retain information, right? Maintain the state. The error handling. If something is failing, it need to replan. Okay. And also in terms of cost also, it can help to route to the cheapest model. If let's say it's an easy task, right, then why you will use the model which is more costly, right? So it can route to the cheapest model also. The cost and token optimization, that orchestrator can help in that way also. Okay. Okay, now one more important thing, agent to agent protocol. So we discuss on MCP, the tool connecting agent. Now agent to agent. So agent to agent is a protocol. Okay. So where you need one agent connect to the different agent, right? So let's say you are developing one customer inquiry agent outside of Salesforce or outside of ServiceNow, right? So if you your agent needs to find the detail from Salesforce, it need to connect to the sales agent. If it need to connect to the service, then it will connect to the ServiceNow agent. So these are in different domain, not in one domain. So it's multi-agent, but the domains are different, agent to agent. Okay. And but how it is different from MCP? Maybe MCP is little bit, it's a kind of a connecting to your tool. If you remember that USB, it's a connector, USB connector, right? But here, this is a protocol for agent to agent communication. It is standardized protocol, right? You can get more details on this. I mean, I can share more detail, but today maybe we cannot discuss more details. But this is, you can imagine, when you need to, it's kind of a cross-domain agents, right? You need to communicate with each other. Then you need to use this protocol. Okay. Now, so then how basically they will coordinate? If there are cross domain, there are multi agents, there must be some standards. We have to put some standards there, right? So there are few basic standards I have given, like consensus algorithm, where each agent, they have their specific value or specific state. They have to agree on that. That's the consensus, right? And the negotiation, that is the JOPA model, you can say zone of possible agreement, right? They have to mutually agree on specific things to move forward, right? That is your negotiation bargaining. And then it's swarm, they work in the swarm manner, right? The decentralized, but they are self organized. There is no central controller. They're decentralized but self-organized to achieve a goal. But it's multi. Okay. So consensus algorithm, the negotiation, and the swarm intelligence. These are basic things I have given here. Okay. Now, one example I've given here. That is, let's say you are designing multi-agent architecture for one, you are just for one item return, you are just returning one item, right? One customer returning item, customer already purchased, but they customer wanted to return that. So how you need to do the design? So the first thing is, of course, you need the orchestrator, who will the central hub and the workflow manager. So it will check the, okay, so let's go with the first step, the initial request. What is the initial request? The return request. Then it will go to the orchestrator. Then the point number two is that this is the sequential delegation, because you have one policy agent. First, you need to check the policy, whether you are eligible for the return or not, right? If you are eligible, then it will move to next step. If not, then it will complete the process at that point. And if it is you are eligible, then what will do? It will go for inventory agent and the refund agent. Inventory, you have to check the inventory, you have to add the inventory, right? And the return, uh, if you are eligible, then it will go for the refund. Okay. And finally, your final communication. Okay. So you have multiple agents here. One agent is your policy agent, another inventory, another refund, another communication. But there are process, if you look at here, the orchestrator controlling everything. It is delegating to policy. That is simple process. But in terms of parallel process here, there are two parallel process. Sorry, one parallel process having inventory agent and the refund agent. They are doing work parallelly. And the finally, final communication. Okay. So this is a classic example of multi-agent architecture having orchestrator. Okay. Okay. Now recall the agentic architecture. First, we have the reasoning. Second, orchestrator or orchestration, and then you have memory. Okay, this is the third part. Fourth part still will go there. The guardrails, etc. Right. So memory is like your working memory. That is a short-term memory. What you are working right now. Okay. Then you have episodic memory. That is recall what happened in the past. Semantic memory. That is store persistent data, kind of a long term. And procedural, store the plan. When the planner, let's say, split the task, then it store those plans. That is your procedural memory. Okay. Okay. Before moving to the fourth architecture block, that is your guardrails. Now, why we need guardrails? Without guardrails, what it can do, the agent can respond rudely. It can leak your PI data, and it can also harm the company brand. But if you are putting some guardrail, it will avoid all these things. Some policies should be there before answering. Even input and output both need to be controlled. Okay. So AI guardrails. So I given into four different category here, four buckets. First is protect against the prompt injection. That is your input filtering. If your input prompt is wrong, right, it should protect that. That is input filtering. Then output filtering, before showing output to the customer or the user, right? You need to filter that. You need to check that whether it's not be hallucinate, right, or it's not violate your policy. That is your output filtering. And then behavioral, it's not answer like it'll on unauthorized action, right? It will protect against unauthorized action. Example given, like modifying, if someone is asking modify financial record, right, that's not the good ask, right? And the content moderation, protect against inappropriate response or bias experience, right? So it's not your response should not be biased, or it's not discriminate any um, anything, right? It related to your answer should not be discriminate, right? So then move to one agent, that is your evaluation agent. Okay. So what it will do, evaluation agent. So you can say it's a kind of a quality control. Okay. So one way you can look at, like you can use LLM itself to manage. Let's say you are using entire agent in one lower model of GPT. Now you can use a higher model of GPT to judge your entire process. Okay. It can be your fact checking grounded with your policy or document, etc. It can be adhere to the rules. Okay. And it can follow the logical steps, and it can match the voice, that tone and prompt, right? You can use LLMH judge also there, or you can, if you have like some process like the deterministic way, you can develop that also be possible. Okay. Now output monitoring. So you have to monitor output. It can be your technical monitoring, it can be your business monitoring. In terms of technical, it can be your system logs, error tracking, the dashboards, etc. And the business monitoring is the most important thing. uh, what is actually uh, I mean you can say the outcome of entire development, agentic development, that is a business outcome, right? In a way, what technical logs tell you if it is ran, but the business monitoring will tell you if it was worth running. Okay. Okay. Now, one more monitoring is important, that is called agentic drift. When your backend model change in GPT you are using, that is, let's upgrade it. Now the agent you developed on top of that model, it's not drift. So if you look at this one, so this is your intended path, but it's drifted to unintended outcome. So for agentic drift, you need to monitor continuously. That should be some monitoring process, some feedback loop, etc. It should check it's grounded on your goals. It's not drift. Okay. So that is one more monitoring. Now, error handling. You have to handle your errors. What error agent is giving. So in terms of if you recall your orchestrator, right? Orchestrator can do that also. If orchestrator is not there, then you should have some process. Then it can retry, it can handle, or it can report those. You should have the fallback mechanism or some alternate paths. And if there is any conflict between the agents, it should resolve that. Okay. Now, test AI agent. So there are multiple way to test. One second one the LLMS judge we have discussed, right? Another way is the trajectory, the entire trajectory evaluation. You have to check the entire steps. In which step, when it's splitted, right? Like decompose the task. In which way decompose, whether it's go in that route or not, or it's mixed and match things. You have to check the entire trajectory and the red teaming, and basically this is test per vulnerability. And imagine something, you develop one agent related to HR, but someone is asking, can I see someone's salary details, right? Or the compensation details. So it's not the correct way, right? So you have to check those things. Test for vulnerability. Okay. Agentic feedback. Agent feedback loop. So this is basically kind of you are giving feedback to the agent to get it back, to make it better, right? So there are multiple ways. You can say the prompt tuning or revision, and provide more examples, store additional context, adjust the available tools, and provide a human in the loop correction. Okay. So but as agent feedback loop is very much necessary, because if you improve the agent the capability or efficiency, you have to work on that feedback loop. Okay. So um, so this is one classic example I have given. I'll show you the code. I have used Creo AI here, is the framework. There are multiple frameworks. You have LangGraph, LangChain, AutoGen. There are multiple tools available. So I used Creo AI because for my example, maybe the Creo AI fit more here. So this example is kind of for the deal desk, okay, entire deal desk process. So I have one orchestrator, or you can say my manager, deal desk manager, and it delegate task to the pricing analyst, the legal counsel, and the sales engineer, and they have their own task. And finally, it synthesize those things or merge things and respond to the supervisor, or you can say the deal desk manager. Okay. Let me show you that example how I develop here. Okay, I prefer this tool. This is your Google Cola. Maybe you must be familiar about this, but because instead of installing any tool, I just wanted to show this is a better tool to work, right? So I'm using OpenAI here as my LLM. Okay, first I installed Creo AI. Then I'm using OpenAI key, and your key should be stored here. Uh, Sorry. Your key should be stored here, and this is a paid tool, paid key I'm using here. And let's look at the first one, your manager, deal desk manager, right? So I just initiated that, initiate here. Okay, Then I have agents. Then I remember the PPT, right? So first I declare all the agents, pricing analyst. I declare the roles, the goals, and the backstory. Same about the legal counsel and the sales engineer. This is another agent. So I so thing is I declare the manager, then the agent, against each agent their role, their goal, and the stories. Though you can say in terms of the instruction I'm passing that the backstory. Okay, and here the task, what task they need to do. I'm assigning tasks against each user. This is pricing analyst, this is legal counsel, and this is sales engineer. Okay, I'm assign the task to them. Then this is the synthesis, the final decision, right? So final decision, the description and the expected output I have given. Okay, that is synthesis process. And this is the final step where I'm declaring my entire hierarchical agent here. So I have agents, this, I have task, I have process, okay, and the manager who is your can say orchestrator or your supervisor here. I have assigned that. Then this one I'm just to test this, I'm evaluating this by passing. But this is my code detail, this is my request, this is my terms, and this is the details about the client in tier. Okay, so this is I am just evaluating my agent. Okay, and this is the kickoff. So it will run. So in similar ways, you can use any framework. As I said, the line graph, that is the most um, I mean that is suitable framework. Also line graph, line chain, 3-way, AutoGen, anything you can use, you can work on that. You don't have to install any tool. That's what I was mentioning earlier, right? So I prefer to use Google Colab here. Okay. Okay, now let's start with the spectrum of AI agent autonomy. So this is basically, let's say you have fair understanding of agent now, agentic architecture now. Now you have to start your agent development, right? But how you should start your agentic journey in your organization? So if you look at this diagram, so I kept it the autonomy in different percent. So you have to start at least okay, so right now in 0%, you have the conventional programming, the traditional workflow you have in your organization, right? So then slowly you have to move to 25% autonomy. The agent you will have the 25% autonomy. So as what agent will do, so it's a kind of assisted or prompted. You just ask some questions, so agent will reply. So there is no kind of orchestration, no reasoning, etc. It's straightforward, simple. Now, slowly you have to move to the 50% autonomy. In the 50% autonomy, you have to develop, you can say the single agent or multi-agent, but with the human intervention, right? So along with human, agent and human, kind of a hybrid model, so it will coordinate with each other, right? That is your 50% autonomy. Then 75%, 75% autonomy. So in 75% autonomy, so agent, kind of it's a semi-autonomous decision maker. So what we can do in this case, we can ask agent to handle the low level task, or where we can ask the agent dedicatedly can handle. The agent will not take any help from the human, but in the complex task where human intervention needed, so we agent will ask human to intervene in that case, right? That is 75%. In 100%, that is complete autonomy, 100% autonomy, that agent will handle everything without any human intervention. So that is anyway, that is very tough. But in terms of, let's say, self-driving car, or you can say the drone system, right? Or one example I've given, like the stock trading, etc., right? So that can possible, but it's very tough to make 100% autonomy, right? So this is entire journey starting from your 0%, 25%, 50%, 75%, 100%. 0.5% you already have, but if you have to start agentic journey, it's in this way. Okay, so let's move to next. So this is my last slide, but this is my understanding. This is entire enterprise architecture for the agentic system. Okay, so look at let's focus on the layer, the third layer, right? So third layer, if you look at here, right now in our organization, there are so many applications, and each and every application, they have their own agentic system. Like let's say Salesforce, we have Agentforce. In ServiceNow, it's Now Assist. In Oracle, there are some, they have their own agentic application. And also in your organization, there must be some custom development agent also. So the problem is, uh, so one thing is they working in their individual domain, and also they are coordinating with each other using agent to agent protocol, right? That is fine. And we should start in this way first, right? And now once your agentic maturity model will evolve or it improve, so what we have to look into is, we should have one unified interface. A unified interface can be anything, your web portal or Slack or any mobile app, and that will be the front facing for the users or the end customers, whatever you can say, right? And so that is my unified interface, and it will come to the federation layer, sorry, the federated and governance layer, where you have the intent classifier, context, and session store, the policy filter, etc. And then those things will be connected to the third layer, right? And of course, we discuss on third layer, and everything is connected to their grounding data layers. They have their own. Okay, so this is enterprise architecture for agentic system, and this is completely my understanding. So it will, I mean, it's depend on the organization to organization. It may vary, but yeah, this is one way of enterprise agentic architecture. Okay. So this is my last slide. Thank you. Thanks for watching. Please, if you like it, so please provide your feedback, and you can like, subscribe, and share. Thank you.